The beginning of any chemistry course is difficult because for us to get far enough along that we can talk about anything of import, you'd have to learn a whole lot of things at the exact same time, and that's not super realistic from either of our standpoints. So, at least for a minute, you're probably going to have to bear with me and know that some topics will become more clear as the course goes along. For now, know that we have to start our discussion of chemistry somewhere, and since chemistry is the study of matter, and since all matter is made up of atoms, the composition of the atom and the atomic theory seem like a good jumping off point. So, atoms are stop number one on our super amazingly fun journey. Since atoms comprise all of the matter that we've come to know and love, we're going to talk about them in terms of the things that they make up, as well as just atoms as a whole. This initial video will really just remind you of the terms that we'll need to get through these first few modules, though. One of the reasons that chemistry courses are difficult for some students is because of all of the vocabulary you need to know. You'll not only need to learn new terms, you're going to need to learn different definitions for some of the terms you already know. And sometimes you'll even have to unlearn and relearn terms, as something might be used in the public vernacular in a different way than the chemist would use it. And from a teaching perspective, that last group's probably the trickiest to overcome. There's not as many words that should be used interchangeably as actually are used interchangeably in a chemistry course. And a lot of those words show up early in our course. So womp womp. So in order to make sure we're all on the same page, here are some bigger picture terms that you've heard before and probably should know how to use, but might not. The first term is going to be the atom. Atoms are the smallest particles we can get that obtain the characteristics of their sample. They're considered indivisible. Yes, they are made of smaller subatomic particles, which we'll discuss more in a bit, but they're made of a very specific ratio of those subatomic particles. The individual particles don't carry the characteristics of the larger sample, but the individual specific grouping of the particles, or the atom, does exhibit the characteristics of the larger sample. This specific grouping is what defines our atom. So atoms are not divisible. They also cannot be created nor destroyed, just simply changed in form. We have all the atoms we have ever had or ever will have. So that's kind of mind-blowing. Our next term is going to be element, which is a substance that consists of only one type of atom. If you have a different type of atom, then you have a different element. Since atoms are too small for us to work with on the individual scale, a sample of an element is the simplest that our samples can get. We'll talk more about identifying elements when we get to section 1.2 and see the periodic table. An element is an example of a pure substance, which is a sample composed of only one type of thing, whether that thing be atoms, molecules, or compounds just in general. And here we introduce our first common misconception in the course, because a pure substance does not have to be an element. It just has to be composed of only one type of thing, not one type of atom. A sample of pure water will consist of only H2O molecules. Pure table salt's composed of nothing but the sodium chloride formula unit. Those molecules I just mentioned are defined as units that contain two or more atoms chemically bonded together. Sometimes those atoms are going to be the same, as is the case with the diatomic elements that were introduced in section N.1. More often, the atoms are of different types, and our molecules therefore consist of different elements. The word molecule is one that gets thrown around a lot more than it should. To be a molecule, your group of atoms have to actually exhibit covalent bonding. Again, more in section N.1, and then much later in module 6, but for now, know that covalent bonding is a sharing of electrons between our two atoms. Only a fairly small portion of the elements on the periodic table can take part in covalent bonding, and the term molecule really only describes this subsection of our substances. Substances that exhibit ionic interactions or metallic bonding, etc., are not actually molecules. The more general word to use is a compound. Any grouping of atoms can be described by the term compound, including the examples I just rattled off. Whatever type of grouping of bound atoms you have, compound covers it. Think in terms of the statement, every square is a rectangle, but not every rectangle is a square. Compound is the more general term, so every molecule will fall under this umbrella, but it does not work the other way around. The majority of this course is going to focus on compounds in one way or another. For instance, by the end of this module, you'll be able to read and even determine mathematically the formula for compounds. In the next module, we will see how compounds and elements come together during chemical reactions to create new compounds. Module 3, you'll quantify the amounts of those compounds or elements that came together in those balanced chemical equations. One very important thing about compounds, they will be composed of atoms. Those atoms will have properties unique to that particular type of atom. But when those atoms combine to form that new compound, the compound has its own unique set of characteristics. We'll only work with pretty simple compounds in this course, but the fact can be used to change atoms in a single position in some giant compound or molecule, and the result can be a completely new set of properties, which is pretty cool and guides a lot of our research. One last term for now, and that's going to be mixture. Mixtures contain two or more types of substances. No, that's not the same definition of a compound. Remember that our compounds were collections of atoms that were chemically bound in some way, covalent bonding, ionic interactions, delocalized electrons, etc. Mixtures generally are not chemically bound and usually can be separated into their constituent components. Think of the caramel cheese popcorn mixture known as Chicago Mix. When you buy it in the store, Garrett's over nuts on Clark any day, it's a mixture of the two types of popcorn. Blindly grabbing a handful results in getting some cheesy popcorn and some caramel popcorn. But if I quickly eat all of the cheesy popcorn out of that handful, I've separated it from the inferior caramel corn and I can unload that on my husband. Chemical mixtures are often at least slightly harder to separate than this popcorn mixture, and you definitely can't eat them, but they're also not that different from this example. Unimportant side note, I love both Chicago and cheesy popcorn. That's definitely not an exhaustive list of terms to recall from previous science courses or education. There's a longer list in the introductory module, and even that one probably isn't exhaustive either. But it will be helpful to a number of you to have these terms in our pocket early as we move through Module 1 and the nomenclature module to keep things a little more clear. Now, on to a discussion of atomic theory, and then eventually the atom.